coming up with the equations. But then after you guys get the equations, most of the time you guys are really good at this stuff. Okay, every once in a while we make a math mistake. Okay, those I'm not too concerned with because I know most of the time you guys know how to do this. Okay, so problem number 1 here. 10 years ago, Thomas was twice as old as Patricia. Okay, so that is one equation by itself. Okay, normally a nice rule of thumb for any math class until you get much more advanced than where we're at right now is normally one sentence is one equation. All right, so 10 years ago, Thomas. So if Thomas is 30 today, 10 years ago, he would have been 20. So we would subtract 10, right? Okay, we don't know how old Thomas is though. So for our equation, we're going to say t minus 10. Was is where our equal sign goes. Twice, so that would mean 2 times as old as Patricia. Remember the whole 10 years ago. So this would be p minus 10. All right, any questions there? Okay, now what we're going to have to do at some point anyways is we're going to have to run this 2 through here, right? So we've got t minus 10 equals 2p minus 20. All right, so that's one of the steps that we'll have to do. You can do it whenever you want. All right, now we do have what we have here is we've got 2 variables. So we've got to have at least 2 equations. Okay, now 5 years from now, so that's 5 years into the future, Thomas, so that's going to be what then? T plus 5. T plus 5, Thomas will be, there's our verb, so that's where our equal sign goes. 10 years older than Patricia. So 10 years older means 10 plus Patricia at that time, so that would be p plus 5. Okay, do you guys see where we got the equations from? Okay, the big part here is this. 10 years ago, you're going to have to use that. And 5 years from now, you're going to have to use that to come up with your equations. Now, it's algebra that most of the time, like I said earlier, most of the time you guys are really good at. Okay, so I would simplify this right side here. So we would have t plus 5 equals p plus 15. All right, what would you do here? Doesn't matter to me. There's lots of different ways to solve it. What's that? Solve for t? Sure. Doesn't matter which one. You could do it for either one, right? So maybe solve both of them for t here, and then you can set them equal to each other. All right, so we'd have to add the 10 over for this one. So we've got t equals 2p, minus 10. And then if we solve the second one for t, we'd subtract the 5 over. So t equals p plus 10. And now, since they're both set equal to t, we can definitely substitute and set the top one equal to the bottom one. So 2p minus 10 equals p plus 10. And then we solve for p, so I'm going to subtract the p over here. And I'm going to add the 10 over at the same time. So we get p equals 20. So Patricia is 20. That would mean that Thomas, how are we going to figure out what Thomas is? Yeah, we just plug it in. Easiest one is probably that one, isn't it? Okay, either one of these, doesn't matter. But 20 plus 10 would mean that Thomas is 30. Okay. Now, like I said, once we get the equations, most of the time you guys are going to get the algebra done to be able to get your answers. Okay. Every once in a while we make a mistake in there, but I've seen your guys' work long enough to know that most of the time, once we get to either this step or this next one, most of the time we're going to get the right answer.
It says Thomas was Westfield. So
that would always change. Okay, 10 years ago though. So if we subtracted 10 years from each one of these guys, Patricia was 10, Thomas was 20, then we got the twice as old. Okay, so that, I mean, and that would happen for everybody. It's only going to happen one time, really. Okay. Okay. All right. Any questions there? Kind of sort of get it? All right. These are going to take a little bit more work though, aren't they? All right. So let's go to the next problem. We've got a lot going on there. Write it down. Yep. One thing, if you guys haven't noticed yet, that is interesting in this book is they never use the same name twice. So in your homework assignments, this problem came right out of the book. In your homework assignments, the names are going to get super weird. And Joe Frank is fairly normal for where this is going to go. Now, this is a problem that technically you can do lots of different ways, okay? But what I'm going to show you is I'm going to show you a way that works. First of all, it works every single time with this sort of problem, and it's going to be transferable to different problems that we'll do later on this year, okay? Now, the big thing is we have to figure out how long the two of them will work together to finish washing the cars. So we could say that however many cars Joe Frank washes plus how many cars Merle washes has to equal 15. Would you agree to that? Okay. Now, for some of those cars, they're going to work together on them. For other cars, maybe they just split up the work and Joe Frank does this batch and Merle does the other batch. Okay, we don't know, but we can do it this way for every single one. All right, now to get this, we need to know how fast Joe Frank can work. So really what we're saying here is we need to know Joe Frank's rate. All right. What would Joe Frank's rate be? How many cars can he wash in 1 hour? What was that? Correct. I need a little bit more specific though. How would we figure it out? How do you figure out rate? 3/5. Yep. How many cars can he wash in 1 hour? Well, you would just take the cars divided by the hours that he worked. Okay, So whether you leave it as a fraction or change it to a decimal, doesn't matter. Okay, you can do it either way. All right, for Merle, what would his rate be? How many cars can he get washed in 1 hour? 4/3. Okay, now, same thing. You could change this to a decimal, but what happens to this decimal here? It repeats, right? It doesn't end. All right, so if you round this decimal, you will get the wrong answer. Okay, so you gotta be careful about that. So if you don't want to have to worry about that, I would just leave the fractions in there, and that's how we're going to do this. Okay, now to figure out how many cars Joe Frank is going to get finished up here, we are going to take his rate and multiply it by the time that he works. Well, we don't know anything about how long he worked, right? So we are just going to put in 3/5 for R and multiply it by T. And then this T would stand for how long they work together. All right, for the next one, we're going to do the exact same thing. We're going to take Merle's rate and multiply it by the time that they work together. So that would be 4/3 times T. And then that equals 15, and we've almost used everything in that paragraph, except for one part. There's one part that we haven't used yet. What's that one part? Joe Frank worked for 2 hours by himself. Okay, so in those 2 hours, how many cars did Joe Frank get washed? How would we figure that out? Right, we would take Joe Frank's rate, which is 3/5, and multiply it by 2. And we would get 6/5 here. Now, in those 2 hours that he worked by himself, he finished 6/5 of a car. We're going to have to subtract that from 15. And that, even though it looks really messed up, that's our equation. Okay. Now, we got to solve for T. T would stand for how long they work together here. All right. So, how do you want to do this? What do we have to do? Common denominators. All right. And in fact, even more so than common denominators, how about we just get rid of the fractions? Can we do that? What do we have to do? Multiply by, we multiply by 15. We're going to get rid of all of our fractions here. So 15 times 3/5 would end up being a 9. 15 times 4/3 is a 20. And then before we multiply those, let's see, if we subtract this right side here, this ends up being 13 4/5. If we take 13 4/5 times 15, we end up getting 207. Okay. Any questions so far? Left side, we just combine our two terms now because they're like terms, right? So 29t over 20 or equals 207. And then we can find our t. We just divide by 29, right? So 207 divided by 29. All right. And technically, that's all the further we would have to go. All right. This down at all. Or it doesn't simplify at all. You could figure out that it's what? It's going to take them a little bit over 7 hours to figure out. Or you can just leave it like this. We label it. All right. A lot going on there. Any questions with where I got anything there? Okay. Next one. That's another one out of the book. You can tell by the names. Maya could empty 2 bottles in 3 hours. Working with Wilbur, she found they could empty 4 bottles in 3 hours. What was Wilbur's rate? All right, now this one would get you thinking that this is really close to the last one, wouldn't it? All right, we know that Maya's rate would be what? 2/3, right? We know their rate working together equals what? 4/3. Okay, now this one gets much simpler than it should be. If we take Maya's rate and then we add Wilbur's rate, it has to equal 4/3. What does X have to be here? It's got to be 2/3, yeah. So what is Wilbur's rate of emptying bottles? 2/3 of a bottle per hour. Okay, so that one ends up being really straightforward. And this one's really frustrating, especially after the last one. When you start thinking that, well, I'm gonna have to do all that stuff that we did for our last one, and this one's a very straightforward equation. Okay, questions at all here? All right, next one. This one's important, write it down. We're gonna see it a lot throughout the rest of the year, and we're gonna use this one in multiple ways here.
That's Friday, the short work to do.
What I will do with your test on Friday is if your test on Friday makes your grade go up, I'll make sure that it's in quarter 1. If it doesn't, if it makes your quarter 1 grade drop, then I will not put it in. Okay. I can do that because quarter 1 grade doesn't matter as far as the semester goes. Okay, does that make sense? So that's the last thing that I will look at. I'll get your tests all graded up, and then I'll figure out for each one of you which quarter it needs to go in, and then I'll adjust your grade accordingly, if that makes sense. So just trust me on that. It'll work out to your advantage. I won't mess with you with having that test on the last day of the quarter. Okay. All right, so we've got, if 5 workers can do 1 job in 8 days, how many workers would it take to do 3 jobs in 7 days? Okay, now this is a new equation that we're going to use. Like I said, we're going to use quite often throughout the year, and that equation, most people remember it as J-word. All right, and this is just jobs equals workers times rate times time. And then we just have to figure out what needs to go where. Okay, now in this one's set up pretty straightforward. We have to use our first situation here to figure out what we're missing. So this is kind of like some of the joint variation problems that we did last year. All right, we've got 5 workers, so that's going in for W. Can do 1 job, that's going in for J. And in 8 days, so that's going to go in for time. We don't know what their rate is. Okay, so we just have to solve for R here. So this would equal, 1 would equal 40R. And we just have to divide the 40 over. So R equals 1 over 40. All right. So we're going to use this rate with our new situation down here. Okay, so same equation. We're still going to have this J-word equation here. We're going to plug in the 1 over 40 for their rate because we're going to assume, even though we might have to add workers, subtract workers, that their rate is going to stay the same. Now we're going to have 3 jobs in 7 days. How many workers do we need to get that finished up? Okay, so we just have to solve for W here. If we want to simplify that right side, we would have 7 over 40 times W. How do we get W by itself? Multiply by the reciprocal. So we're going to multiply both sides by 40 over 7. So W equals 120 over 7. So once again, 7 doesn't go into 120 at all. So if you wanted to, you could figure it out as a mixed number, but you don't have to. You can definitely just leave it like that. All right, now this is kind of what stores go through and trying to figure out how many workers they need to hire to get their job done. Okay, they do the same concept. They don't necessarily write this equation, but they do the same concept. And they will definitely do this concept around holiday time, okay? Because, you know, they're already starting to advertise that they need holiday workers, all right? How many more workers do they need? Well, they go through this concept to try and figure it out, okay? Now, when you get a fractional worker, then they have to make the choice at this point. You know, do we hire just 17? Do we hire 18? Do we hire all of those for the entire time? Or do we say, all right, we're going to hire 17 full workers, and then this extra worker, they're only going to work like 1 day a week or something like that, okay? But that's how they kind of use this information to figure out who they need to hire. All right, so just make sure you label this stuff up. All right, but that's kind of the concept behind it. All right, and like I said, a lot of our stores use this concept to figure out how many people they need to hire, for how many hours, and so on. Okay, questions at all with this one? If I remember right, yeah, we're gonna do the same thing with this one. So get this one written down. Even though we're going to use that J-word equation, I don't see any jobs, workers, rate, or, well, there's time up there. But we got to figure out what goes where for this. All right, so we know Mary had 252 gallons of milk. This would feed 42 infants for 12 days. Then 14 more infants were placed in the nursery and 48 more gallons were provided. How long will the milk last? All right, now, the ladies down in the cafeteria, do this concept with you guys. Okay, it's a little bit easier because most of the time we're still going to have the same amount of kids that eat lunch just about every day. All right, so they can kind of estimate it based on that, but they still do this concept. All right, so as we said earlier, this is going to be a J-word problem again. All right, we've just got to figure out what is going to go where. All right, now we're going to have to use our original information here for our original equation. All right, what are things that we know? We know the time. We know the time is 12 days. So we can start there. Who would be the workers here? It'd be the infants, okay? So you don't normally think that infants are workers, but it would be in this case because their job is to drink the milk, right? So that would mean that our job would be the 252 here. So we still have to figure out what the rate is. Okay, so we take the 42 times 12, we get 504 times the rate equals 252. Divide the 504 over, and we find that our rate is 0.5. Okay, so then we have to use the rest of the information to be able to figure out t here. How long would it take, or how long will it last? That's solving for t. We know that our rate is 0.5. How many workers do we have this time? 14 more than we already had, right? So we're gonna have to take this 14 and add it to 42. So we get 56. And how many gallons of milk do we have now? 300. Yep, we're gonna have to add these 48 to what we already had. All right, so 56 times a half is 28 times t equals 300. Divide the 28 over. That would definitely simplify down. So I would change it to a decimal at that point. So this would be, so our time would be 10.7 what here? Time would be days, yeah. Okay, now it's super easy to get your label kind of messed up there. Pay attention to what you're solving for. All right, just be careful of it. All right, so 10.7 days, okay? A lot going on there, okay? For what a lot of you guys are going into, this is the type of stuff that you need to practice, okay? Not necessarily saying you're gonna use the algebra part of it, but sometimes you gotta make your situation that you're dealing with at work kind of make sense. And if you can put it into an equation, well, then we can solve it, okay? But really, this is just another logical process that we can use, okay? And this is just an equation that works for us. All right, any questions here? All right, give me a second. I screwed up my video. So I'm gonna go back here and say to these guys that even though they had a black screen that they were looking at, we talked through all this. So here are the notes for the first problem. I would write all of this stuff down and then go back to listen to the video. And the same thing for the second one. All right, write all of that down and then go back and listen to what we talked about here in class. The other ones is when I remembered to show what we were doing here. So, all right, so those of you here that had nothing to do with you guys, your homework assignment is, what do we do? Lesson 25, and you're gonna do 1 through 22. Okay, so get that written down first, and then, then we're gonna talk a little bit about studying for tests. And this goes for a lot of stuff in college, all right, whether it's math tests or any class. All right, so what I sent you, and not all of your college professors are going to do this, but what I sent you was, I sent you that list of lessons. All right, so really what this says is the lessons 1 through 15, except for lesson 4, right? I did say in there that lesson 3, there's 2 problems in there. Lesson 5 is 2, 6 is 2, 10, 11, and 13. There's all 2 problems on the test from each one of those. Okay, so what I want you to do, I want you to grab your book, open up to lesson 1 really quick. All right, now normally I don't tell you to look at your book when you study. You can definitely study your notes if you take a good set. I know not all of you do though. All right, so you're gonna have to figure out what works for you. But if you open up to lesson 1, all right, a lot of this was a lot of the basic geometry. Okay, so what I would go through is I would look through the first page and I'm like, okay, points, lines, I get it. I'm not gonna spend a whole lot of time on that. Okay, and I keep going through this and I'm like, all right, this is basic geometry. I'm not really doing a whole lot of math. You know, I'm kind of flipping through, you know, obtuse angles, acute angles, you know, those I already understand. I keep flipping through. Then we've got triangles. I kind of get those. Okay, maybe I get to lesson 7 and I look at alternate and corresponding angles. Okay, there's a little bit more detail on that. I might have to look through and see what's going on there. Okay, but I look at it. All right, I get that vertical angles always equal each other. Okay, corresponding angles have to add up to, or corresponding are going to be the same. Okay, any 2 angles that make a straight line are going to have to add up to 180. All right, but for the most part, I get that stuff. All right, area. That's where I started to see a little bit more issues on the last test, right? We've got to know area of a triangle. Okay, so I would start making a list of different equations that I need to know. And that's the first one that I've seen on page 9, area of a triangle. Now, most of you have it down. Okay, and I don't think anybody screwed up that equation on the test. But then I go down one and I see area of a circle. That one kind of surprised me that we don't have that one down, because that one's been kind of pounded into your guys' brains for a long time. So there's another equation, okay, that you have to know. I flip the page, and then we've got area of a sector, okay? Now that was one of the problems that was on the test, right? On the last test. All right, so maybe you got that one wrong and you didn't understand why you got that one wrong. Well, they show on page 10, they show exactly how to do it, okay? So the area of the shaded region, it says, is 234 degrees. So I've got 234 over 360. And then I take that times the area of the whole circle, so pi r squared, okay? And then when you multiply it all out, you can either leave it as 13 pi or you can multiply it together. It doesn't matter to me. On my answer key, I always have both answers because I'll have kids that do it both ways, and it doesn't matter. Okay, so that was the big equation, I would say, from lesson 1. Okay, pages 11, or just page 11, they're going through a little bit more conceptual stuff. Okay, so just make sure you look through that. Okay, I would maybe star example 1.4. Make sure we understand that one. Don't write in my book, Sarah. Okay, maybe put a star in the notes that you're taking on what I'm talking about now, right? Okay, and then what I would do is if I understood lesson 1, I'm going to skip all the problems that are at the end of that, okay? Because if I understood all that, I probably don't need to practice those. But say that I didn't know the area of the sector. I might go through and I might look at these problems, and if I look at number 26, look at number 26 in lesson 1 there. All right, that's an area of a sector problem. You guys have the answer key. You could practice that one really quick. Don't check the answer key until you're done, but then get that all worked out, then check it. If you got the right answer, then you know what you're doing, okay? Because a lot of the rest of the stuff in this problem, or in this problem set, was just review stuff that, you know, we practiced a little bit, but you should kind of know for stuff in the future. All right. Then we go on to lesson 2. Lesson 2, more area of a triangle. All right. So we've already got that one written down. Flip to the next page. And this is where it's starting to have a little bit more formulas here. All right. And the formulas show up on page 19. All right, so where they start talking about surface area of a prism, we need to know that equation. And then volume and surface area of a cone at the bottom of page 19. Okay, and at the bottom of 19, they put it into words. If you flip the page to page 20, you have that equation in there somewhere. All right. And this is where I would definitely use your notes for this stuff, because we wrote down those equations if you looked at that. Okay, and I would keep running through stuff like that. Okay, lesson 2 is big into equations. I counted out on this test 10 out of the 20 questions you have to use equations for. Okay, if you don't know the equations, you're kind of screwed. Right? Okay, so you got to know the equations for this. So start making a list in lesson 2. Okay, so and there's a ton of them for surface area and volume. All right, then let's flip to lesson 3, because that one says that there's two problems in that. Okay, so the one that you guys did a really good job overall. Okay, the first equation type thing that I see there is the whole tell whether it's an obtuse triangle or an acute triangle. All right, so we're using Pythagorean theorem. If the two smaller sides are bigger than the bigger side, then it's acute. If the two smaller sides squared are less than the biggest side squared, then it's obtuse. Okay, and like I said, overall you guys did a good job with that. Okay, so I would say, based on what you guys showed me on the first test, I wouldn't spend a ton of time on that. All right, and I would just keep running through lesson 3, maybe get to example 2, where we did have a little bit more problems. It's on page 30. All right, we've got 2 triangles there. Now what I would do for lesson 30, or for that problem on page 30, is I might draw the triangles in the same orientation. So if you look at the right triangle, we've got a 6 and y. For the other triangle, let me show this to you guys watching this. All right, so we got 6, 7, and y in that orientation. I would want to flip the left triangle to make it the same. All right, opposite this angle that we know, that's going to be our 4. This one down here is angle 2. So this would be angle 2 down here also. In between angle 1 and angle 2 in the left triangle would be our 5. And then our x would go up there. Draw them in the same orientation to help you out there. And then, most of you know, we can just set up proportions here, right? So this is x over 6 equals 5 over 7. And then you just cross multiply and solve. Okay? I wouldn't necessarily do it the way they do it in the book. It's a little bit more complicated. You get the same answer. But that's probably the easier way to do it. Okay? You flip the page to 31. Well, you see another problem that's very similar to it. If you need to draw them out in the same orientation, do it. Okay? I think for some of you that would help. For some of you, that's a waste of time because you can see it. But for some of you that can't necessarily see it, draw it out. It's okay. It'll only take a little bit longer to be able to get there. All right? And then I would flip to page 33. Okay? And I would almost guarantee that that thing is on there, where we have 3 triangles here, right? They are all similar. All right. Now remember, for this one, I would highly recommend breaking these into 3 similar triangles in the same orientation and label them upright. Okay. If there is one that I would guess you guys need to study, make sure you have down for Friday, I would guess it's this example 3.5 on page 33. Okay. Any questions there? Do you guys kind of see what I would do studying wise? All right. If we flip to lesson 4, we don't have anything. I did want to touch on a couple of the other ones. Lesson 5. All right, lesson 5. I would almost guarantee there's going to be one from example 1, 2, or 3 on there. Okay, and there wasn't one on the last test, right? So I would practice those, get those kind of more down. And then, okay, the one thing that I probably wouldn't study so much, if you go to page 46, example 10 there, that was on the last test, wasn't it? Okay. Now you guys have seen enough Saxon tests to know that if it was on one, it's probably not going to be on the next one. Okay. Now, which kind of stinks for a lot of you because I know you guys got it. I've seen your test corrections. A lot of you got it figured out. Okay. So it's not a big deal. All right. So if I did put it on there, you should be good to go. But what that ends up being is it ends up being a bunch of, it ends up being 2 triangles. We're using Pythagorean theorem to solve. Okay. All right. So if you haven't figured it out yet, let's see. Example 10 and 11 show you how to walk through those steps to be able to get it. Okay. And then if we go to lesson 6, I think lesson 6 was a 2. Yep, there's 2 questions on a lesson 6. All right. I look at example 1 there. That was on the last test, right? I would make sure I understand how to do that. Okay, and you can do it lots of different ways. You can either get rid of the fractions by multiplying everything by a common denominator, or you could subtract the 4/7 over to get 1 fraction equals another fraction. And then you can cross multiply and solve. It's kind of up to you. I know the book has it done one way. In class, we did it a different way. It all depends on what you want to do there. Okay. Flip the page though. You look at example 2. Most of the time, you guys are really good at example 2. Okay. Get rid of the fractions, get rid of the decimals. Okay. Most of the time, you guys got those. Okay. Example 4 though. I would definitely look at example 4. All right. So in fact, we're going to do example 4 really quick. So square root of s minus 48 plus square root of s equals 8. All right. Now, What a lot of you guys tried to do is you guys saw, all right, square roots. I got to get rid of the square roots. I'm just going to square everything. All right. You cannot do that because of this plus sign. Okay. So do not do that. Instead, what you have to do first is you have to get this square root of s over to the other side. This bigger square root here, get that all by itself. That is in your best interest. So this is going to stay here. Square root of s is going to go to the other side. Now, we're going to square this side. And we're going to square this side. Left side just ends up being s minus 48. The right side is 8 minus square root of s times 8 minus the square root of s. You have to FOIL this out. So this would be 64 minus 8 times the square root of s minus 8 square root of s. So this would be a 16 square root of s. When you add those like terms together, and then to get your last one, it's going to be negative square root of s times negative square root of s would be a positive s. Okay, now we're down to just one square root here. Okay, from here we got to get this square root of s by itself. So we're going to subtract the s's, subtract the 64s. S's go away here. This would end up being negative 112 equals negative 16 square root of s. You guys know from here, we divide by negative 16. And that ends up being 7, I think. Pretty sure, yeah. So we would get 7 equals square root of s. And then once you get here, you guys are fine. Okay, we square both sides. S equals 49. Okay, but these first two steps here, you have to subtract the square root of s over to the other side, and then you have to square both sides here. And when you square the right side, you have to FOIL this out. A lot of people will forget this term. Okay, and then you'll come back to me and say, my s's are all gone, I can't figure this out. All right, and it's because you messed up a step. Okay, so definitely take a look at that. That is normally a problem area for most kids, is that sort of problem. Okay, and we said that there's 2 questions out of this lesson. I would say that there's a pretty good chance that this would be on the test. Okay, if you flip the page to 52, you got a 3 equation, 3 variable one, right? Most of the time you guys do fairly well at those, even as complicated as they end up getting. All right, I would say if you are completely comfortable with it, skip it. Okay, if you know that you screw that up every once in a while, well, maybe do that example 6-6 there, because then you have the answer down at the bottom of the page. Okay, so that would be something that I would look into. All right, but that wasn't anything that was equations wise, right? If you look at lesson 7 then, this was more of the inductive deductive reasoning where you have to figure out if it's valid or not. If I remember it, you guys did really well on that part of it. Okay, the one thing that I would tell you, okay, is figure out where your verb is and put an equal sign there. So whatever the sentence is. So for example, let's go to page 57, and it says, no, we're not going to do that one. 56, all normal dogs have 4 legs. So your verb is have. So we've got normal dogs here and 4 legs here. And then for the second one, that dog has is the equal sign, 4 legs. All right, whenever the same thing is on the same side, it is always invalid. Okay, if you go through example 7.3 and you see how have is your verb, we have chickens on the left side And then you go down to the second one, Henny Penny is a chicken. Chicken would be on the right side, right? When these are cross from each other. And your therefore sentence puts these two pieces together, then it's always valid. Okay, so that should help a little bit. On the test, I believe they ended up both being on the same side, so it's more like the top one there. All right, so that's one way that you can tell that it's valid or invalid. Okay, I would guess that one of these is going to be on the test. Okay. All right, any questions there? All right, go to lesson 8. Now, if you start to look through lesson 8, not a whole lot of equations there, but you do have similar triangles, right? So we should be, like if you look at the bottom of page 62, you got that big triangle with a line going through the middle. There's 2 triangles there. If you need to, split them into 2 again. All right, and label up those triangles, kind of like they did on the bottom of page 62 there. All right, that will help a lot of you. Okay, bottom of page 63 would be an equation. All right, where when you have to deal with angle bisectors, a bisector will make it so that the left side, the ratio of the left side equals the ratio of the right side. And they have an example on how they did that on page 64. Okay. And then I would just keep going through stuff like that. Okay. Now, studying for every single one of you should be very particular towards you. Okay. If I am studying with somebody else and I look through, say, lesson 9. Lesson 9 is the first proof one. All right. If I start looking through that and I'm like, I understand proofs, I'm fine with proofs, but whoever I'm working with doesn't have a clue, well, they are going to have to look through lesson 9, right? You might be able to help them, but you know, if you understand proofs really well, I wouldn't spend a whole lot of time on it. Okay, I would look through those examples, like on page 70, kind of looking through how they did it, just to give you an idea. All right, or page 71. But if you've got proofs down and you understand it, then skip it. And based on your homework, you guys are great at proofs. I know that's not necessarily the case, and I got a feeling I'll find out on Friday, but make sure you look that stuff over. Okay? And then I would just keep going through stuff like that. Okay? There are a lot of equations. Like I said, half the test you have to use an equation for. All right, big equation that you have to know is on page 87. Take a look at page 87. There's a whole bunch of stuff on that page, but there's only one equation that we truly need to know. What is it? Quadratic formula. Okay, one of the biggest equations in really all of math. All right, if you know a quadratic formula and you know how to find slope, you should be able to do a lot of stuff that we do in math with just those 2. All right, we haven't done a ton of stuff in here with slope, but quadratic formula is huge. Okay, and remember, like if you look at the bottom of 87, example 11.6, it says use the quadratic formula. I'm not going to tell you how to do it. If you want to factor it instead and it factors, then factor it. Okay, if you want to, I believe it's lesson 12. No, I don't know where it's at. Where they start talking about completing the square. If you want to do that, you can. I think it's a waste of time. I think it's way harder than it has to be. So I would never do it that way, and I don't care how you solve it. Okay, lesson 13 is the last one I wanted to touch on really quick. Okay, where you have circles and you have lines going through them. Now, the nice thing is not complicated equations, but there's a lot of equations in there, isn't there? Okay, there are 2 questions on the test out of lesson 13. And unfortunately, you're going to have to know those different equations. Okay, I broke them down really easy in your notes. So if you had good notes on lesson 13, that'd be the way I would go. Okay, and starting on what, lesson 10 or so, I think I started making videos just about every day. So you can always go back and watch the videos for these different lessons if you don't remember how to do it. Okay, but that's pretty much how I would study for these tests. Okay, I would go all through every lesson that I give you, and that's what I would do. Okay, so hopefully that helps. Like I said, big thing for this test is you have to know your equations. Okay, like I said, 10 out of the 20 questions, you have to use